Today's topic, workgroup bridges, autonomous workgroup bridges. That's the only type of workgroup bridges I guess we have. Before we get into actually configurations and things like that, let's kind of talk about what is a workgroup bridge, what are the features that come along with it, and then I guess what's unique about workgroup bridges, when would you use them as opposed to some of our other options that do sort of the same type of thing. Okay, so a workgroup bridge is an autonomous access point first and foremost. So it is a standalone access point. It's not part of a controller-based solution. And it's meant to connect a separate wired network to another wired network across a wireless connection. So it's bridging really two wired connections together across a wireless medium. Now, we have actually a couple options to achieve that same goal. Those other options being, at least in the autonomous world, a non-RIT bridge does the same type of thing. It connects two wired networks across a wireless medium. On the unified side, we have mesh, which can do bridging as well. So why would we use a workgroup bridge over some of these other solutions? What's unique about the workgroup bridge that would lead us towards using that type of a solution? Well, one, we already talked about workgroup bridge is an autonomous AP. So if you want something that's a standalone type of configuration, doesn't rely on any sort of a unified solution, definitely that's one reason to move towards the workgroup bridge solution. But how about workgroup bridge versus RIT, non-RIT? What's really the differences there? Let me kind of whiteboard this out a little bit so you can kind of keep track of this. So we'll have workgroup bridge versus RIT, non-RIT. Similar, but some differences in what they do. All right, so obviously, if we need to bridge wired nets together, yep, both of them do that. If you need something that's sort of robust and scalable, that's more the RIT, non-RIT bridge. Robust. Workgroup bridges are mainly for connecting small networks together. It's maybe just a dozen devices or one device, two devices, things like that. You're probably not going to use a workgroup bridge to connect two separate buildings with their own networks together across a wireless link building to building where you have 1,000 users over here and 1,000 users over there, and use a workgroup bridge to connect them up. That's going a bit far with a workgroup bridge. That's where you're using more of a RIT, non-RIT bridge, because the RIT, non-RIT bridge can scale to pretty much, it doesn't matter how many devices are on either end of a RIT, non-RIT bridge. They're just passing traffic through. Whatever traffic comes in one side just gets spit out the other, and it's not doing anything special in terms of keeping track of all the devices or things like that. Whereas a workgroup bridge is actually connecting up as sort of a special client. So the SSID that's connecting up to the WLAN it's connecting up to is really just a client serving WLAN. It's the same WLAN that my laptop can connect up to or my smartphone can connect up to. The workgroup bridge also connects up to it too as a client, but then does a little bit of special magic to announce itself that I am a workgroup bridge and here are all the devices behind me. So it's telling the AP that's connecting up to every device behind it. Since it has to tell it every device behind it, that's where we can start getting to those scalability issues where, if we have thousands of devices behind it, that doesn't work so well. So scalability is one thing that would drive you towards, RIT, non-RIT versus a workgroup bridge. Mobility. Usually the workgroup bridge is a lot better for a mobile solution, whereas RIT, non-RIT bridge are usually very stationary. It's like sort of a building-to-building type connection, whereas a workgroup bridge, it could be stationary, absolutely. It could just be, sitting in one spot, connected to a switch, which is connected to a number of devices that are just too far away to run a wired connection to the main network. But you could also put a workgroup bridge on some sort of mobile device and use that as connection for wired devices to the network. Classic example would be a forklift. Maybe the forklift has a PC on it, a special little PC running some sort of inventory program or whatever. It's telling the forklift driver where do I need to go, what do I need to pick up, things like that. But unfortunately, the PC that's on that forklift doesn't have a wireless network card. So what are you going to do? What you can do is then plug that wired device into a workgroup bridge, and the workgroup bridge essentially becomes just a remote wireless network card. Now the workgroup bridge does the connection up to the wireless network, and they can roam around, and the workgroup bridge roams around just fine, giving those wired devices wireless connectivity. So mobility is definitely one thing that would drive you towards using a workgroup bridge. And then again, we're keeping things usually pretty small with that workgroup bridge. Let's see, get my notes up. What else? So VLAN support, multiple VLANs. If you need to support multiple VLANs across your bridged connection, that's definitely a forte of the non-RIP bridge. It inherently does this automatically. Now the workgroup bridge can do it as well, but most of the time we use these as one VLAN type solutions because we are doing a lot smaller deployments, and there's additional configs you need to do just to turn this on. By default, it only supports one VLAN. So while you can support multiple VLANs on both of them, really that's a forte of the non-RIP bridge. Yes, workgroup bridges can do it, but it's sort of not the native functionality. And it's not typically, usually the networks behind a workgroup bridge aren't that large where you are needing multiple VLANs, but it can support it if you need to. Okay, I think that should be the big thing. And then I guess the other thing is, the workgroup bridge again is connecting up to a WLAN that's serving many different types of clients, whereas non-RIP bridge are very specific. You usually don't have regular laptops and smartphones connecting up to a WLAN used to support this non-RIP bridge connection. You can, but typically they're sort of standalone connections specifically for connecting these two devices, whereas workgroup bridges are just tagging along on a client serving WLAN and performing just this special operation on top of that. So the main use cases then for workgroup bridge. Smaller wired networks that you need to connect up to another wired network. The nice thing about workgroup bridge can connect up to another autonomous AP or a unified AP, so you have more options in terms of where you're connecting up a workgroup bridge to. So flexibility with that. It's great if you need this to be mobile, so if it needs to be on a mobile device running around, workgroup bridges work very well with that. And yeah, if you don't want to have to use a dedicated, RIT AP like you would do with a RIT non-RIT, if you just want to just use your normal client-serving infrastructure that you've already got out there, whether it's autonomous or lightweight, workgroup bridge immediately connects up to that, as opposed to having a standalone RIT AP for every workgroup bridge to have to connect up to like you would with a RIT non-RIT type bridge. So that's a little bit about workgroup bridges, why you would use a workgroup bridge over some of the other kind of competing options with that. So the rest of the time here is really just going to show off the functionality of the workgroup bridges, a lot of the different features and just different ways to do the same thing, connecting up a workgroup bridge to an autonomous AP or connecting up a workgroup bridge to a unified AP, single VLAN versus multiple VLANs, as well as a few of the other special things that we can do with workgroup bridge. So before we get into that, let's kind of show you the topology that we're going to be working through with all of our examples here. So on the left-hand side here, we have sort of our main network. So on the main network, we have an autonomous AP on the bottom here, and that will be advertising an SSID called Auto WGB-Pod1 on VLAN 110. So when I want to connect up to an autonomous AP, I have a different SSID I'm going to be connecting up to, as opposed to the lightweight AP above it, which is advertising a WLAN called Unified WGB-Pod1. So this is how I'm going to control whether I'm connecting up to an autonomous AP or unified, just by different SSIDs. But they're both using VLAN 110 by default. And LAP1 here is connected up to a wireless LAN controller. So it's just a normal local mode AP going up to a controller. Now on the right side, we have our workgroup bridge. That's going to be autonomous AP2. And then this autonomous AP is connected up to a switch, Cat3, in our deployment, but that Cat3 is connected to nothing else. So we really have two fully severed networks. The larger network on the left-hand side and then the one switch behind AEP2, and then we'll be, we'll have some SVIs on Cat3 as well as some other devices that we can use to sort of ping across this workgroup bridge connection. And we'll be able to show you, single VLAN as well as multiple VLAN type things. And when we get into multiple VLANs, we'll be talking VLANs 11 and 12 as well as 110, which is sort of the management VLAN that we're using on our APs here. Okay, so there's the topology. First example we're going to get into then is going to be creating just a single a single VLAN connections. So kind of the classic workgroup bridge type of a network connection. And we'll do it first to the Autonomous AP, show you that, and then we'll do it to the Unified AP and just show you, what are the differences as we configure things up like this and behavioral differences. All right, someone is saying cannot see anything. Okay, is anyone having problems seeing what I'm showing you here, the topology? You're okay? Okay, good. Just want to make sure that we're seeing this before I move on. All right. Well, let's go ahead and take a look at my Autonomous AP1 just to kind of see what we're working with right now. So right now on Autonomous AP1, I have created an SSID already called Auto Workgroup Bridge Pod 1. We've assigned it to VLAN 110, and it's just a WPA2 pre-shared key style network. We're not going to get into different types of these networks because that's not really in the scope of the conversation here. Honestly, the type of SSID and the security going around it is completely irrelevant to workgroup bridges. Workgroup bridges can connect up to, pre-shared keys, EAP authenticating networks, plain open networks. Honestly, it doesn't matter what type of an SSID it is. Basically, we just need an SSID working on some AP, and then our Autonomous AP just connects up to that SSID as a client. So we'll just be doing WPA2 pre-shared key throughout the course of this, just for your reference here. But if we look at show IP in brief, we can see that I have created the VLANs, at least on the root AP of Autonomous AP1 here. So we do have VLANs 11, 12, and 110 already staged up on here. 110 is the native VLAN, and that's where the SSID is being used on. So all clients, by default, when they connect up to this SSID, will be placed on VLAN 110. So, and then we'll be using the 2.4 gigahertz radio, which is already up and running. As you can see, .11 radio 0 is our 2.4 radio. So that's what we'll be using for our connections here. And then on Autonomous AP2, we're at pretty much a blank slate. Show IP in brief. We do have an IP address on the BVI. It's a static IP address. So here's the management IP address, 10.10.110.101. I have a default gateway, but I haven't done anything else beyond that. I haven't configured an SSID, haven't done anything on the radios yet. It's pretty much plain Jane at the moment. So first, let's start off. We'll configure this as an Autonomous AP to connect up to the Autonomous AP1. So since we're not going to do multiple VLANs to begin with, I'm going to leave it as is. So if you only need to support one VLAN, you don't need to configure any sub interfaces. You can just leave the physical interfaces configured as is, and that'll work just fine. So on Autonomous AP1, first thing we need to do is we need to configure the SSID on Autonomous AP2 to connect up to our Autonomous AP1. So the easiest way for me to do that is I'll just snag it right out of the running config. Now just about everything applies here, except that, pull up a notepad here. Since I'm not using VLANs on Autonomous AP2, I don't need to specify that. But we're just going to say, it's a WPA2 SSID, and it's using a pre-shared key. And as long as the pre-shared keys match, authentication should work just fine. So I'm just going to take that and copy it into Autonomous AP2. If I go to my radio now, and I need to define the encryption to say we're using AES encryption. So encryption, mode ciphers, AES. Assign the SSID to the interface. So SSID Auto Workgroup Bridge Pod 1. And now we need to say this is a workgroup bridge. So on the radio we say station role workgroup bridge. And finally no shut. Once we say that it's a workgroup bridge, what it's going to do is basically bring up the radio, and then it's going to look for another access point to associate up to. So we have an SSID, we know to associate up to that one. It's not going to be advertising its own SSID, so it's just a client. It's not servicing any other wireless devices or anything like that. So we see that it has associated up. If we go to Autonomous AP1, we should be able to see that association, show .11 associations. Here it is. So the bottom line here is the actual Autonomous AP connection. So we see that it is a workgroup bridge. And then on top of that, we're going to start seeing one or more workgroup bridge client connections. So these are all the devices really behind the workgroup bridge. So as I kind of mentioned before, the root AP is really going to be keeping track of every single device behind the workgroup bridge, and if I don't have the entry on AP1 of the device behind the workgroup bridge, nothing on this side of the network can communicate across to the device on the other side of the workgroup bridge, at least from a unicast perspective here. So what determines what shows up as a workgroup bridge client? Well, it's anything technically that shows up in the bridging table of the workgroup bridge on its Ethernet interface. So if I do a show bridge entry, anything that's assigned to fast Ethernet 0, so something that lives on the other side of its Ethernet connection, will show up as a workgroup bridge client. So here we have, the MAC address ending in BC84. That's our entry that we see here. And as we get more devices that show up in the bridge table of Autonomous AP2, what it does is it advertises these clients up to its root AP using a protocol called IAPP, which I think stands for Inter-Access Point Protocol. So there's some special magic happening between the workgroup bridge and the AP that's connected up to say, here are all the devices behind me. So it's doing something special on top of just being a regular client. So if I want to get another client behind there, for instance on Cat3, we can actually see show IP int brief exclude unassigned. I have a number of SVIs configured so we can use these to ping across from Cat3 across the workgroup bridge connection to the network behind it. So I have a VLAN 110 interface, so if I ping 10.10.110.1, the default gateway, which lives actually on the other side, what we should get, hopefully, is things working. Not quite yet. So other thing I forgot to kind of check is our wired ports connecting up to our autonomous APs. Now, anytime we bridge things across a wireless, we do wired bridging across a wireless medium, we have to be very cognizant of how we configure the switch ports that connect up to our devices. So let's see how we have these configured. Cat1 connects to Autonomous AP1 on port FA022. It should be a trunk, so let's do a show in trunk. All right, so on FA022, we see it is a trunk. We have a native VLAN of 110 and an allowed VLANs list of 11, 12, and 110. So it's set up to trunk and support all the VLANs that we care about. Now on Cat3, which plugs into Autonomous AP2, I believe we should just be in an access port. So show in status, we'll just look at connected interfaces here. All right, so we are connected and we are in an access port on VLAN 110. But let's go ahead and take a look at one thing here. Show spanning tree int FA02. Okay, so we're in a broken state in spanning tree. One thing that's going to happen is the normal, from the switch port perspective, it looks like these two ports are actually physically plugged into each other. So from Cat3's perspective, it looks like switch 1 is plugged into port FA02, and from switch 1's perspective, it looks like Cat3 is plugged into port FA02 over there as well. So right now we have a trunk on one side and an access port on the other. So if you think about, okay, if we just actually plugged into these, these ports as a wired connection to each other, how would that flesh out? Well, unfortunately, we run into a problem where we see this error up here where we received an 802.1q BPDU, a trunk BPDU, on our interface, but our interface is an access port, and that's going to cause a problem. So if you have to do some sort of a scenario like this where it's a trunk on the root and an access port on the non-root, you pretty much have to either do one of two things. Either turn spanning tree off, which can be a dangerous proposition, especially if you have the potential for any sort of loop somewhere, or you have to make the port a trunk port But to replicate an access port, you just basically allow one VLAN and make that VLAN the native VLAN. So I'm just going to turn off spanning tree in this instance because I'm going to need to turn it off a little bit later as well. So do a no spanning tree VLAN 110. Now this is basically going to just stop using spanning tree, so it will stop blocking spanning tree in that case, and then I believe we should be working. So if we do a show spanning tree in FA02, now we don't have any spanning tree info, so it's not blocking. Try to ping across 10.10.110.1. And there we go. If we look on AP2, we'll see that we have another MAC address, actually a couple more MAC addresses in the bridging table on Fast Ethernet 0. So now we should have 3 workgroup bridge clients listed on Autonomous AP1 if we look at that. Show .11 associations. There we do, we have 3. So one of them we haven't learned an IP address for, but the other couple we have. Sorry, 2 we haven't learned an IP address for. So, but we do have 3 clients, and again, whatever shows up as a client here is just whatever shows up on the workgroup bridge assigned in the bridge table assigned to the Ethernet interface. Okay. So here we have basic one VLAN type of setup working. We have a VLAN 110 client behind the workgroup bridge communicating across up to the other network. Okay. So pretty simple in that respect. Let me move this out of your way here. What about if we wanted to do the same thing, but instead of associating up to an autonomous AP, we want to associate up to a unified AP? Well, all we really need to do is just the same type of config on AP2, but instead of configuring the SSID for the autonomous AP, we just configure the SSID for the unified AP, and we don't really need to do anything else differently. So let's go ahead and do that. So what I'm going to do is I'm going to take away the SSID, show run include SSID. So we're going to get rid of the autonomous SSID and just replace it with the unified SSID. Let's get rid of that. And I've got the config just pre-staged here just to save ourselves a little bit of time. But it's the same thing. All we're doing is configuring, again, it's a WPA2 pre-shared key style network. Go into my radio, assign the SSID to the radio. It's already in workgroup bridge mode, so once the SSID goes live, the radio is going to come up. And we see that associated up to, we even see the AP that associated up to LAP1. And now we should be on there. So let's go ahead and take a look at our controller, and we should be able to see this on the controller side. Okay, here's wireless LAN controller 1. We can see on here we just have one AP, LAP1. And if we look at our client sessions now, we should see a number. Again, it's the same type of thing. Whatever we see here is going to be the workgroup bridge plus all the clients, which would be anything in the bridge table of the workgroup bridge assigned to the Ethernet interface. So the workgroup bridge will show up with the protocol. Anything with the NA protocol would be the clients. If we scroll over here, though, we can actually see that this is actually a workgroup bridge. So we can click into our workgroup bridge entry. We see here's a CCX v5 client, which are, Cisco APs are CCX v5. We see it's a workgroup bridge. How many clients are behind this workgroup bridge? What VLAN it's been assigned to? We see that it made it into the run state, so it's fully authenticated up on the network. A few other things here. And then we can look at the actual clients. For instance, let's try this one. Yep. So here's a workgroup bridge client, but we see IP address, MAC address, same type of information that's on VLAN 110. It made it into the run state. And it inherits a lot of this stuff. It inherits the security that the SSID is using, the QoS type stuff. It inherits that as well. And then on the unified side, you don't need to do anything special. For just a single VLAN workgroup bridge client, you just configure the SSID just as you would for any other client serving SSID. Workgroup bridge connects up, advertises its clients, so no special extra stuff you have to do on the unified side for that. Okay, So that's at the most basic level, connecting a workgroup bridge. We can have multiple devices behind the workgroup bridge, all in the same VLAN, whether it's connecting up to an autonomous AP or connecting up to a unified AP. Any questions on those types of examples? Okay, so we have our workgroup bridge connected up. Now, one thing that the workgroup bridge might need to do is roaming. Well, the default behavior of roaming of our access points is actually pretty poor. From my understanding, what's going to happen is basically once they connect up to an access point, they'll connect up to the best access point that they can find. But once they're on that access point, supposedly they're just going to sort of hang on for dear life until they just can't communicate to it anymore. So they'll just go down to the lowest possible data rate. Once they can't support that anymore, then they leave. And then they'll find another AP to associate up to. Well, it's not the most intelligent way to do roaming. So in our code, we can actually get some more intelligent roaming. And that's with the mobile station command. And these are actually CLI only commands. So let's go ahead and take a look at that on our autonomous AP. So on AP2, what you do is you'd go into the radio configuration. So I think I'm already there, but let's go back in there. So I'm on my radio where we have the workgroup bridge station role configured. And there's a series of commands called mobile station. This is going to give us our enhanced roaming. And within here, we could just turn it on. This just turns on sort of enhanced roaming just generically. So I could just hit enter, and now it's at least going to roam a little bit more intelligently. But I have a number of other options. Let's talk about what those options are. So we can see, we'll just go from bottom to top here. So scan. What channels do I want to scan? If I know all the APs I could possibly associate up to are on channels 1, 6, and 11, why do I want to scan every single possible channel? It's going to take it that much longer to find a valid AP to actually associate up to. So with here, I could actually say mobile station scan 1, 6, 11. There we go. And now, as long as my APs are only using channels 1, 6, and 11, make sure you do that, it'll find them a lot faster. So it's an efficiency mechanism in terms of scanning for better APs. What else do we have here? Period. So, how long should it take to scan through our list of channels? We can specify a number of seconds, say it's 15 seconds. And then we can also set a threshold. So the threshold says, when do I start scanning? So I could say, we need to represent this as a positive number, but if I said 75, basically what's going to happen is if I have, if I'm already on my AP with an RSSI better than -75, I don't bother scanning because I'm at a good enough signal. I don't need to worry about scanning it. But once I hit that threshold, then I'm going to start scanning for a better AP possibly to associate up to. Okay, minimum rate. I think this is what's maybe causing this flapping here. So what's the minimum data rate that I'll either stay connected to an access point on or that I need to achieve in order to roam to another access point? So this is really your bottom floor for staying on an access point. So I'll go ahead and say 5.5 megabits a second. So as long as I can maintain a data rate of 5.5 megabits a second, I'll stay on an AP. If I need to roam to another AP, I'm only going to roam to the other AP if I can at least achieve a data rate of 5.5 megabits a second. And then the last one that we had is this ignore neighbor list. So one of the roaming enhancements with CCX are these neighbor list advertisements. Basically, we're just saying ignore that list if you want. Not quite as helpful, in my opinion, but the other ones are definitely very useful in terms of efficiency and really controlling when roaming should happen and saying our minimum standards for staying onto an access point. So mobile station series of commands, very helpful if your access point actually needs to be roaming around the building, or if you're in an environment where you could have a lot of obstructions moving in and out and changing the landscape of the RF. So, great, I had awesome connection to the signal, but now they just, moved a device between me and it, and I should probably move to this other access point now. That's another scenario where the mobile station commands can help you out with a workgroup bridge. Okay. How about reliable multicast? So this is, according to the infrastructure, whatever it's connected up to, It's pretty much a client, it's a regular client that does some extra stuff. But it's going to treat it more like a regular client than it is going to treat it more like this infrastructure connection, like a root non-root bridge type of connection would treat it as. So, if we have all these, a number of devices behind the workgroup bridge, those devices behind the workgroup bridge might need to receive some multicast packets from, some part of the main network. Well, normally the way that multicasts are sent across a wireless network is they're sent in an unacknowledged state. So basically, the root AP would send out the multicast packet to all of its clients. It just sends out one single multicast packet. If it makes it there, great. If it doesn't, there's no acknowledgement expected. So if the packet is lost in transit between the AP and the client, which would be the workgroup bridge, it's lost for good, and the devices behind the workgroup bridge aren't going to get it. So since we do have sort of this infrastructure type connection, we probably want to be able to support a little bit more reliable multicast delivery from the main network across the wireless network to the devices behind the workgroup bridge. The way to do that with a workgroup bridge type of connection is to go on the root AP, and so we're going to have to flip over, back over to our Autonomous here. So let's flip that real quick. Just 1 second. No.11 SSID. Get our Autonomous SSID back in there. And finally go to the radio, SSID, Auto Workgroup Bridge, Pod 1. So we'll get back to our Autonomous connection here. There we go. Now we see it, show .11 associations on our Autonomous AP. Perfect. So on the Autonomous AP, the root AP that the workgroup bridge is connecting up to, what we need to go to is config T, go to the radio interface that we're connecting up to. So in this case, 2.4 gigahertz radio. And we put in the command infrastructure client. What this command says is that any workgroup bridges associated up to this radio, we'll treat them as an infrastructure device, which means we're going to give them reliable multicast. So how does a reliable multicast work? Well, it's going to function kind of like this. So we have our root AP, we have our workgroup bridge, and a number of other clients. Because this is just a normal client serving SSID here, and then behind the workgroup bridge we have a number of wired clients here. So a multicast packet comes flowing in to the root AP. Once we turn on infrastructure client, what's going to happen is the root AP is still going to send out the normal broadcasted multicast packet. So just the normal multicast packet that it sends to everyone, that unacknowledged multicast packet. So it sends out the unacked frame. Someone wants to come in. And then both clients are going to receive that because it's just sort of broadcasted out there to everyone. And then in addition to that unacknowledged frame, it's going to send an additional copy of that to every single workgroup bridge on the radio. So it's going to, this one's pretty much sent to everyone, but then an additional one is going to be sort of a unicasted multicast, directed at each individual workgroup bridge. So if there's 10 workgroup bridges, we'll send the one sort of unacknowledged broadcasted multicast frame, and then 10 individual unicasted multicast frame to each, one to each workgroup bridge associated up to this root. So if it's a unicasted packet, it gets acknowledged. So if the packet gets lost over the air, the workgroup bridge doesn't acknowledge, the root AP knows to then resend that packet until it finally gets an acknowledgement from the workgroup bridge. And then that way we get a reliable delivery from the root to each workgroup bridge, which is awesome. So now we can get this reliable multicast, and all the clients behind the workgroup bridge can make sure that they're going to get every single multicast packet pretty much. Well, we do have one issue with that. Now what's going to happen is every single workgroup bridge is going to get 2 copies of every multicast packet. One, it gets the unicasted multicast packet, and 2, it gets this broadcasted multicast packet. So both of those packets by default will get sent back to the client. So the clients are going to get 2 copies essentially of every single multicast packet, which is less than ideal. So how can we kind of prevent this dual multicast packet scenario? Well, if we go to our workgroup bridge, we actually have a command in there. So on our radio, when we do that station role workgroup bridge command to say that this is a workgroup bridge, we also have this extra option for a multicast mode. And here we say, okay, since I can be receiving broadcasted multicast and unicasted multicast, which one do I want to forward on to the guys behind me, and which one do I just want to ignore? This is where we get the client and infrastructure. So client mode, as it says, accepts only 3 MAC address header multicast. So hopefully most of us know that a normal wireless packet has 3 MAC addresses in it. 2 of them are for radios, and 1 of them is for a device behind, the AP or the client, whatever it's going to be. The 4 MAC address comes in when we have these bridging scenarios. So we could kind of draw this out real quick. So let's just say we have client A on a root AP, workgroup bridge, client B. So as this frame is flying across the air, if it's unicasted, we honestly have 4 MAC addresses that we can use. So the 4 MAC addresses really signify the 2 radios in play, the root AP's radio and the workgroup bridges AP radio, as well as the clients on either side of this bridge. Because ultimately what we're trying to do is get a packet from client A to client B. So one of the MAC addresses is going to be client A, because when it gets to client B needs to know ultimately that the packet came from client A. Client B will be the other one, because ultimately we're trying to get it to specifically client B. And then we have the root radio, because this workgroup bridge needs to know what radio it came from, so that if it has to send back something back to the radio, it needs to know, to get something to client A, this is the intermediary radio that I need to send it through to get it to client A. Same thing with the root. The root needs to know, to get it to client B, it has to tell it first to go through the workgroup bridge. So we need to target the MAC address of the workgroup bridge as well. Workgroup bridge, radio. So this is where we can get 4 MACs in. Anytime we do wireless bridging of 2 wired devices, that's when we get into 4 MAC addresses. If it was just a client here, we would only have 3 MAC addresses. The client A, the root's radio, and then the client's MAC address. So only when we get these wired bridging scenarios is where we get into 4 MAC address. So which packets do we care about? Do we care about the 3 MAC address one or the 4 MAC address one? Well, technically we can choose either one, but if we've gone through the effort to turn on this infrastructure mode where we're sending these reliable multicasts, that's probably the one we want to send back because it's reliable. We always know that we're going to get this, but the 3 MAC address one, those broadcast multicast ones, that's kind of a crapshoot. So almost exclusively, you would probably want to say infrastructure. And now I'm only forwarding those unicasted multicast packets to the devices behind me. I'll just drop the broadcasted multicast packets. So once you turn on infrastructure client on the root, come in here and choose probably infrastructure for the multicast mode, but choose one of them so you don't have these duplication of multicast packets to your clients behind you. Okay. Any questions on that or on the roaming enhancements that we talked about? All right. Well, let's talk about supporting multiple VLANs then on a workgroup bridge. Now, this is definitely a much less known feature with workgroup bridges. I actually didn't know it for quite a while that it even supported it because they don't really talk about it, honestly, very much in a lot of the Cisco documentation, at least in the autonomous world where they have just the normal workgroup bridge documents. It's honestly hard to find. There's some talk of it in a mesh, connecting a workgroup bridge up to a mesh network document. and there's a mention about it in NetPro forum, but not widely publicized. So in order to make this work, we actually need to do a few things. One, we need to get the VLANs configured on the workgroup bridge to support this multiple VLANs. But depending on what we're connecting up to, either an autonomous AP or a unified AP, we have to do a couple extra configs, just depending on what we're doing to actually enable the multiple VLAN support. Otherwise, you get these weird types of behaviors going on. So we'll start off talking about multiple VLANs to an autonomous AP connection, since we're already on an autonomous AP here. So in order to do this, first thing I need to do is start configuring extra VLANs on my workgroup bridge. Now, there's actually two sort of possibilities that we can kind of do here. One, we could just specify one additional VLAN where all the clients are placed onto that's different than the VLAN associated to the WLAN. So what this would look like. So let's say I have my Autonomous AP1, and the WLAN is going out on VLAN 110. Okay, my workgroup bridge is over here. My workgroup bridge has an IP address on VLAN 110, but all the clients behind it should be placed on VLAN 11. Okay, well, we have a mismatch here then. We have a WLAN that's assigned to VLAN 110, but I have clients on VLAN 111. I can configure the workgroup bridge to say, basically, okay, all the clients coming through, just put them on VLAN 11 instead of VLAN 110. Normally where you would use this method is if you had, probably that this is a hub. And the hub doesn't support, tagging traffic on different VLANs up to the workgroup bridge. So basically every packet coming into the workgroup bridge is just going to be untagged because the device behind it has no capabilities of tagging the traffic. So we just have to tell the workgroup bridge, okay, yeah, I know the WLAN is on 110 here, but the clients behind you are supposed to be on VLAN 11. So how can we make this specific scenario work? Well, first step, configure some VLANs on our Autonomous AP2, the workgroup bridge. So I'll just do this in the CLI. You can do this however you want, but I would just say configure the VLANs on all interfaces. So we're going to be having two VLANs in play, at least in this scenario. We have VLAN 110, which is where our WLAN is going to be living, and then we have VLAN 11, which is where the wireless clients behind the workgroup bridge are going to be living. So let's create those two VLANs. So I'll go AP2 and create the 110 VLAN interface, and we're going to put it onto VLAN 110, and we'll make it the native VLAN. And then I'll replicate this out to the radio interfaces. Oops, D0. And I should be putting this in bridge group 1. D1. And then we'll create the VLAN 11. Interface 0.11, encapsulation.1q 11, bridge group 11. And put it on the radios. And once I'm done, I know this is a little sloppy, so we'll just kind of take a look at it when I'm done here. All right, show IP and brief. Sorry, I'll do it one more time here. Okay, so we can see that we have created basically a VLAN 11 and VLAN 110 interface on every single interface, both radios and the fast Ethernet. Now, technically, I don't need these everywhere, but I find it just makes life a whole lot easier if you do put it everywhere, and then you don't really have to worry about not having a VLAN where you need it. So I have VLAN 11 and 110. Now I need to tweak my SSID to say my SSID should be assigned to VLAN 111. So let's go back to my SSID. Auto workgroup bridge, pod 1, VLAN 110, sorry, the VLAN's on 110. Okay, so at this point, I'm connected up, show.11 associations. I was connected up. Oh, I need to change my my encryption as well. Encryption VLAN 110 mode ciphers AES. And that should get me going. Okay, so we've associated up, and at this point, we're still not quite working yet. Everything's still going to be associated to VLAN 110. So what I need to do is on AP2, say that with the workgroup bridge client VLAN command, basically say, okay, all the client packets coming in untagged on my Ethernet interface, when I send them up to my upstream AP, place them on VLAN 11. Now this does require on the root AP that infrastructure client command. Infrastructure client is always required anytime we need to support multiple VLANs. So it gives us the reliable multicast. It also enables multiple VLAN support on the upstream access point. And then the last thing we need to pay attention to is our switch port connected to this. So we want to put the switch port for my workgroup bridge into VLAN 111 because these are supposed to be VLAN 111 or VLAN 11 clients. Switch port access VLAN, how about that? All right, so, and then we're going to need to turn off spanning tree on that one again. No spanning tree, VLAN 11. Because now we're definitely getting this VLAN mismatch where the untagged on the far end side is VLAN 110, and that comes over, and it's on VLAN 11 now. It's also trunked to an access port, so it doesn't like that either. So again, you can get into these wonky spanning tree issues once you start doing bridging. So ideally, if you can just make both sides trunks and the native VLANs match on each other. Otherwise, you do have to do these tricks where you start turning on spanning tree or at least do some sort of BPDU filtering type thing to stop these BPDUs from sending across. Always be paying attention to what's going on with spanning tree on your ports. Okay, so now we should hopefully be set up so that all the VLAN stuff, VLAN 11 stuff's coming into the workgroup bridge, being sent across to the root AP and being placed on VLAN 11. So let's go ahead on Cat3. I have a VLAN 11 interface. So let's try to ping something on VLAN 11. 10.10.11.1, default gateway. That worked. Let's go ahead and take a look at my root AP. Show.11 associations. Okay, so now I'm starting to see some stuff on different VLANs. So the workgroup bridge is on VLAN 110, but the clients behind the workgroup bridge are now being placed on VLAN 11. If we take a look at the details of this association, here we see that it is indeed assigning this client to VLAN 11. So what did we do special to do this? Created the VLANs on Autonomous AP2, both on the radios as well as the Ethernet port. On the Autonomous AP, we did that workgroup bridge client VLAN command to say, okay, what VLAN should all the clients behind the workgroup bridge be assigned to? And then on Autonomous AP1, that one also needed the VLANs, which we had from before, and it needed that infrastructure client command to support multiple VLANs at the same time. So that's one way to do multiple VLANs. And the only time you really do that one, this is really a corner case one, when you have a device behind the workgroup bridge that doesn't support tagging. Now, if we do have a device behind the workgroup bridge that does support tagging, a little bit more intelligent switch, then we can just have the workgroup bridge just read the tag as it comes in and use that information to tell its upstream AP what VLAN these clients should be associated up to. So let's go ahead and show you that one. So I honestly don't need to change anything on AP1. Everything's already ready on AP1. All this is going to be on AP2 now. So I can take away this command. I don't need that workgroup bridge client VLAN command anymore. And I just need to create I'll go ahead and be bridging VLANs 11, 12, and 110. So I just need to get that VLAN 12 up there. So let's create that real quick. And FA012, encapsulation.1Q12, bridge group 12. Put it on the radios. Come on. Show IP int brief. Now we should see I have the VLAN 12 interface everywhere. Okay, that's really all I should need to do on the worker bridge. The last step is then go to the switch port connected to Autonomous AP2 and actually make it a trunk. So let's go ahead and do that. And now I should actually be able to turn on spanning tree again, because now if you look switch to switch, the port connected to AP1 is a trunk, the port connected to AP2 is a trunk. It's going to be native VLAN 110 on this side, native VLAN 110 on the other side. So everything's going to be matching, and we shouldn't have any spanning tree issues at this point. But let's go ahead and try that. So in FA02, we're going to do a switch port trunk encapsulation.1q, switch port mode trunk, switch port trunk native VLAN 110, and finally switch port trunk allowed VLAN 11 through 12 and 110. Let's take a look at that trunk config real quick, make sure I didn't screw anything up. So it's trunking with AO2.1q, 110 is the native, we're allowing 11 through 12, and 110, this completely matches what I have on the Autonomous AP1 side of things. And let's go ahead and turn spanning tree back on. Spanning tree, VLAN 11, and 110. Okay, let's take a look at spanning tree on our port now. Show spanning tree int FA02. Okay, so this is the connection to my workgroup bridge. What am I seeing here? Well, I see that all 3 VLANs are actually on, and I'm actually seeing that they're seeing that this port is the root port for all VLANs, which means BPDUs are flowing across, which kind of goes back to, not only do we want to make sure that we have, worry about spanning tree in terms of, if this is a trunk, the other side should ideally be a trunk, same native VLANs, things like that. This is a valid spanning tree path, so we do not want to be using things like BPDU guard or port fast or usually BPDU filter, because now this can create a loop in the layer 2 network if you're not careful. So we want to have the protection of spanning tree where it goes through that listening and learning phase to make sure, okay, should this be forwarding? Should this be blocking? We don't want to immediately go into forwarding, and if I turn on BPDU guard, it's probably just going to knock the port out into an error disable mode right away. So always be thinking about spanning tree consequences to doing this type of bridging. But since I'm seeing root on all of them, that means BPDUs are flowing across. I should have connectivity across all 3 VLANs now. So let's go ahead and try. Do some pings from cat3, ping 10.10, 11.1, 12.1, 110.1. These will all be just connected interface pinging. So looks good. What do I see on AP1? Show.11 associations. I see clients across all different VLANs. They're all showing up as workgroup bridge clients. We should be good. So to support multiple clients, if the device behind the workgroup bridge can tag things, a little bit simpler. So all we need to make sure is that on the workgroup bridge, we create all the VLANs that we want to trunk across. And then make sure that the switch port connected to the workgroup bridge is also set to trunk those. On the root AP, make sure we have the same VLANs, that the switch port connected to it is set to trunk. And then all we needed was that infrastructure client command on the radio of the root AP to support the multiple VLANs. So it's a little bit simpler solution when you can actually do it this way rather than having to do the client VLAN command over on the workgroup bridge side. Questions on at least multiple VLANs with the autonomous connectivity? Otherwise, we'll go ahead and show us doing it to the unified world. Okay, so doing this on the unified world. On our workgroup bridge here, we've already set the stage where we've created all the sub interfaces, so that's half the battle right there, just getting all those VLANs created on the AP. We have everything trunked okay on our switch. Now we just need to associate up to a unified access point, and we need to configure a couple extra things to make this work in the unified world. So we'll start on the workgroup bridge since I'm already here. So let's go ahead and take off the autonomous SSID. And I'll slap in the unified SSID. All right, so we just created the same SSID, but now we're connecting up to a unified access point. Go to my radio, SSID, unified workgroup bridge, pod 1. This should give me my connection. Okay, I'm connected up, but it still is not going to work until I do two things here. One's on the workgroup bridge. So if I get back to my global config, workgroup bridge, unified VLAN client. This is going to enable it for a unified connection on the workgroup bridge. Then I got to go to my wireless LAN controller. So if I go to WLC1 where my access point is joined up to, I actually need to configure, configure workgroup bridge VLAN enable. This is turned off by default, so we need to turn it on both sides. We need it on the controller side and on our workgroup bridge side. But once I have both of those, as long as on my wireless LAN controller I have the interfaces for VLANs 11 and 12, we should be able to bridge those up. So let's see if this is working. Okay, 110 is working. How about my non WLAN, VLAN? So the VLAN is, or the WLAN is on 110, but 11 is working now. How about 12? And there we go. If we go up to our wireless LAN controller, should be able to see our clients that are divvied up onto these different VLANs. So here's all of our clients again, but if we start clicking in on them, we'll see, so we have one on VLAN 110, we have one on VLAN 11, VLAN 12. So here we have it working in a unified world. It's a very similar type of configuration, but we have two extra pieces of config. One is on the workgroup bridge with that workgroup bridge unified VLAN client, and then on the controller itself is configure workgroup bridge VLAN enable to make it receptive on the unified side of things. Okay. Any questions on getting the multiple VLANs working in a unified world? And again, make sure that your controller has those VLAN 11, VLAN 12 interfaces to actually drop them off onto. Okay, then there's one other thing I want to kind of talk about. It's just sort of a little weird state that you can run into with things in the workgroup bridge world, and then we'll kind of wrap things up for the lecture here. So, on the workgroup bridge, as I've been referencing up until this point, the root AP, whether it's autonomous or unified, is keeping track of every wired device behind that workgroup bridge. So if any packet comes into the workgroup, the root AP destined towards a client on the other side of that workgroup bridge, the root AP is only going to forward that packet across if the foreign client is in the associations list. So, for instance, on Autonomous AP1, show .11 associations, which I don't have it right now because it's not in there. But if I scroll up to the associations list from what we had, if it's not on this list, it will not forward the packet to the far end device. So in order for traffic to work in a scenario like this, root, workgroup bridge. So for traffic to flow in kind of a left to right pattern, when it gets to the root AP here, it's going to evaluate, okay, is the destination for this packet in my associations list? If it is, I'll forward it on. If it's not, I'm just going to drop it right there. So this behavior and the fact that the only thing that shows up on the root AP is what's in the bridging table of the workgroup bridge can cause you to get into these black hole scenarios if the device behind the workgroup bridge is not speaking very often. Sometimes we refer to it as a passive device. So here's the scenario that you can get into, and we'll give you a couple of options to sort of remedy the situation. So let's just say we have a simple setup. We have client A over here, client B over here, and we'll just pretend that they're on the same VLAN just for simplicity's sake. Okay. Let's just say client B's IP address is just 1.1.1.1 because it's fast to write. All right, client A is 1.1.1.2. Client A wants to ping or send some piece of traffic to client B. Well, what's the first thing client A has to do in order, if it says, client A says ping 1111. The first thing it has to do, since it's on the same VLAN, is resolve this IP address to a MAC address because ultimately we need to target the layer 2 MAC address of client B. So what does it do? It sends an ARP. So client A sends an ARP. So it's going to say ARP to 1.1.1.1. Basically, what's the MAC address for 1.1.1.1? ARPs are broadcast traffic. Makes its way to the root AP. Now, ARPs are one thing that will be forwarded across this wireless network by default. So the root AP sees, okay, this is an ARP packet. I'll go ahead and forward it on. Makes its way to the workgroup bridge. Workgroup bridge forwards it on to the client behind it. Okay, client receives it. We still don't have the client in the root AP's association table because the client B basically came up and has never said anything ever. So it's not in the workgroup bridges bridging table, which means it's not on the root AP's association list. Well, the ARP makes it to the client B. What's the client B going to do? It's going to respond to the ARP. So it sends back the response, makes its way to the workgroup bridge. Workgroup bridge now received a packet from client B, which puts it into its bridge table. So basically it sees, 1.1.1.1. The MAC address assigned to that is on the Ethernet port, which advertises it to the root AP, and it also forwards this on. So at this point, client A knows the MAC address for client B. The root AP has an association entry for client B because the response from the ARP populated it in the workgroup bridge, which then populated it into the root AP. Awesome. Now client A can send its ping, which is a unicast packet, makes its way to the root AP. The root takes a look at the packet, says, okay, who is this destined to? It's destined to 1.1.1.1. Is this in my associations table? Yes, it is. I'll forward it on. Makes its way over here. Client B receives it, sends it back. Everything's happy, and there's communications flowing. Awesome. Okay, well, now let's pretend that, okay, well, the communication's done. Client B goes back to being sort of this passive client. It's not really talking to anything. What's going to happen? Well, eventually, its entry will time out of the bridge table from the workgroup bridge. And this doesn't take very long. I don't know if it's just a handful of minutes by default. Once that happens, that's erased. It removes it from the root AP, so it's no longer in the root AP's association. .11 associations, it was there. Now it's gone. But client A still has it in its ARP table because ARP tables usually persist for many hours. What's going to happen? Client A wants to talk to client B again. Okay, we'll start a new conversation, sends a unicast packet to 1.1.1.1. The root receives it, looks it up, and says, I don't know, I don't have an entry for this IP address or this device, so I'm going to drop it. And client A just keeps on trying this over and over and over again because it knows the MAC address in its ARP table, so it's not going to re-ARP until the ARP table times out. So it's going to be in the state where the bridge table timeout is much lower than the ARP timeout, so the difference is where we're black holing traffic. So how can we remediate this issue? Because different clients can have different ARP timers, so you never know exactly what the ARP timeout is going to be on the client. So you really have two options, and they're both going to be on the workgroup bridge. So we can either increase the bridge table timeout to a very large value so that the bridge timeout is ideally as long or longer than any of the ARP timeouts over here. But even if that's the case, you can still run into these scenarios. Or actually, sorry, you won't run into that scenario. So as long as the bridge table timer is higher than the ARP timers, you'll be okay because the ARP timer will always time out first, causing new ARPs to happen, refreshing the bridging table entries. Or we can do a static bridge table entry and just say, okay, here's the match of 1.1.1.1 matches to, sorry, in the bridge table it's just MAC address. So basically we just say this MAC address lives on the Ethernet port, and it's pretty much nailed up there, which nails up the association on the root AP. So either way works. Let me show you how to configure either one. All right, so on the workgroup bridge, we can either increase the bridging table, so you would say, okay, which bridge group is this associated with? Normally, we have a one-to-one mapping of bridge groups to VLANs. So if you're not sure, you could always do a show show bridge and just see, okay, well, where is it right now? So we can see, okay, bridge group 1, is it under that? No. Here's bridge group 12, is it under bridge group 12? Yep, there it is. So that's one way to figure out what bridge group it's on. Or if you just know your bridge group to VLAN mappings, that's fine too. But we would just say something like bridge group 12 for if it's on VLAN 12, aging time, and we could just max it out if you wanted to, or set it to something appropriate. Now, obviously, this will keep these bridge entries around, so if you have lots of clients coming in and out, it will persist these entries for a lot longer than they should, but most of the time with workgroup bridges, pretty small networks, it's not the worst thing in the world having a few extra sessions out there. And at worst, this is just a handful of days, 5 or 6 days, maybe something like that. So it's not horrendous. It's not like it's a month or something like that. So I could just pop that in. There we go. All right. Now anything that makes its way into the bridge group table is going to stay there for a very long time, much longer than the ARP timeouts. If I don't want to do that, I can pre-populate static MAC address entries. And if you know specifically the client, this might be a better way, but it is more of a manual process because you would have to do this for every single client that's kind of falling under this category. But to do that, so first do show bridge. So let's pop in a permanent entry for, we'll say this guy here. So right now it's on bridge group 1. So bridge group, sorry, 1, get into the bridge group number. Address, what's the MAC address? We'll just paste it right in. And we want forward. And it would be fast Ethernet 0. What was it on? It's easiest just to look at the entry. It makes life easier at .110. Now when I look at the bridging table, it's still there, but now the age is P, which means it's a permanent entry. It's never going to time out, which means it will always be in its upstream AP's association table. So we never run into the issue there. So 2 ways to do it, either a dynamic method, where we just use, we dynamically learn it, but we remember it for a really long time, or we're going to statically define it on the workgroup bridge. So either way gets you to the end result that you want. It's just depending on if you have a lot of these types of devices, the dynamic method might be a little bit easier because it's just a one-time command as opposed to, maybe doing 8 different static entries or whatever it's going to be. Okay, let me make sure I didn't miss any topics, but that should be pretty much the end of it. So any questions on anything, on what I just talked about here, or just anything else in regards to workgroup bridges in general that you might have questions upon, I can definitely try to answer any of those other questions at this time now. But if we don't get any other questions, we'll probably call it a session here. So we'll keep watching here, but definitely appreciate you guys popping in. You will see this recorded up on our YouTube channel, so either later today or pretty quickly. We will have this on YouTube, so you can come back and watch it over again if you need to, or tell your friends, or whatever it's going to be. All right, see what Kevin has to say. Otherwise, if he doesn't have anything, okay. Appreciate you guys popping in here. Again, pay attention. We'll have more of these V-lectures, usually once every month, going on different topics. Generally CCIE focused, but we'll try to focus in or broaden them so that they apply to both, just day-to-day type of work too, in addition to the lab. So appreciate it again. You guys have a great rest of your day here, and hopefully we'll see you next time.